right, this is the last set of notes for the semester, right? 5-5, which I will do over 2 videos. First video will be setting it up, and then the second video will be applications. So 5.5, we're just going to look at applications, a special type of application called consumer and producer surplus. Right? So these are special applications that involve area under a supply and demand functions. Alright, so when we have a competitive economy, the total amount the consumers actually spend is usually less than the total amount they're willing to spend. Alright, that extra amount that the consumers felt like they kept in their pocket is what's considered the consumer surplus, which I like to simplify as CS. Alright, so my capital C, capital S stands for my consumer surplus. Alright, the formulation, right, where the consumer surplus comes from. Alright, so this CS, consumer surplus. In vernacular, it's just the amount they're willing to spend minus the actual amount they spent. Alright, it's the leftover in their pocket. Alright, they didn't spend this money, but they would have been willing to spend that money. Would have been willing to pay a little more for the product. Alright, so graphically, this involves the price demand function. Alright, where P is the price of my item, right, and that's the y-axis. Q is the x value, that's the quantity of items sold at that price in my market, right? Price and quantity fluctuate depending on the market's price, right? Higher the price, the fewer they sell, the lower the price, the more they sell. All right, so again, there's a direct relationship between price and quantity in our market. All right, so first the picture. So graphically, alright, so if I graph the picture, again, we only graph in the first quadrant, we only have positive prices and positive quantities. And so this is my price, the x-axis is the price, usually price. The x-axis is quantity, alright, number of items sold. The y-axis is the price, usually in dollars per item, although it could be in hundreds of dollars per item. Right, like I said, we graph it in the first quadrant. Alright, so the demand curve is always decreasing, right? There's a lower demand if price is higher. Alright, there's a higher demand when price is lower, right? That's why sales stimulate. When the price is lowered, right, it stimulates sales. Alright, so usually we start up here. This would be where we'd start the demand at, if we set our price to 0, this is how many we'd sell if we were giving it away. Alright, and then it decreases after that. A lot of ours are going to be parabola shapes or linear shapes. So again, it's always a decreasing though. There's my demand function. Alright, there's usually so this would be the market price. Ours typically is going to be at equilibrium, so this is where our market is at. Alright, again, ours are going to typically stay at equilibrium. Alright, but I'm just going to put a generic quantity and a generic price. Alright, this is our current market level. So this is our current price, and this is our current level of sales, quantity sold. Alright, and like I said, when we get to our examples, that market will be at what I call equilibrium. We'll talk about that in a little bit. Alright, so here's my demand curve. This dotted line, this box shape is important. Alright, this is where the current market level is at. Alright, they're currently selling, this would be the current price. And this would be the current number of items sold. Alright, which means this box area is our revenue. Right? Because revenue is price times quantity. And so this area is price times quantity, right? As it would be this box, this rectangular area, which would be quantity and price, right? Our base is quantity 0 to Q, and our height is price. And so this dotted area is how much they spent, right? This is the revenue generated from sales, right? This would be the dollar amount they spent. All right, that's what that area, that box area represents. Which means this area above that rectangle that's under my demand curve, this area that I've shaded in, All right, it's above that rectangle but below our demand curve. That's the consumer surplus area. That's the amount of money that was left in the consumer's pocket. That's the amount that some consumers would have been willing to spend. All right, so again, that's the consumer surplus area. That's what we're looking for. We want to find this area. All right, just this one that I've shaded in, the area above that rectangle, area above that revenue rectangle. All right, so I'm going to set up the formula, how this is done. It's going to involve an integration, right? It's a area under a curve, so it's an integral. So it is going to involve an integration. And so what we want, I'm going to pick a different color. All right, so this is our revenue. So this pink area is our revenue. And this highlighted area, which is the blue that I shaded in earlier, that's the consumer surplus. Well, if you look at the total area there, the pink plus the yellow, it represents the area under my demand curve from 0 to my current quantity, right? That's the total area. And so we're going to use that in order to find the area that I'm looking for. All right, so if I set up my formula, right, I'm going to write my formula. So up here, I'm going to write it. My consumer surplus formula in words, it's the area under the demand curve from x equals 0 to x equals our current level of production, this Q amount here. All right, that's our current level of production, minus the revenue. Minus that price times quantity, right? That box area. All right, that's what we're looking for, right? If I take the total area, right, total area, the pink plus the yellow, that would be the area under my demand curve from 0 to Q, right? That total area would be an integration of my demand curve from 0 to Q. Well, I don't want the total area. I only want this area that lands above that pink area. All right, well, I subtract away the area I don't want, which is easy to find. The area I don't want is whatever my price is times whatever my quantity is. And so that's in words. And so the formula, which again you can either remember or you can formulate based on the picture, is the area under the demand curve from 0 to my quantity, which is a integral, so I'm integrating 0 to Q of my demand function. Minus the current level of the revenue, the current price times the current quantity, right? That's the revenue, P times Q. Whatever this would be, again, a number. All right, we're selling 50 items at a price of $100, all right? And so revenue is the amount you generate from sales. And so that would be what the consumer surplus is, right? So it's integrating the area under the demand function minus the revenue, and then I'm left over with the area I want, right? I've got this area up here that I'm looking for. All right, that's the consumer surplus. All right, the other type of problem, which we'll combine these in a little bit, is the producer surplus. So this is looking from the other direction. So now I'm looking from the producer's viewpoint, all right? The manufacturer, the guy's providing the item, the supplier. All right, so the supplier, this involves the supply function. So PS is how I shorten producer instead of writing out. So when you see that P, capital S, that means my producer surplus. All right, involves the supply function. All right, so the producer surplus is the extra money the producer felt like they got from the revenue. They would have been willing to settle for lower prices and less quantity sold. All right, but they didn't have to. All right, and so this would be the extra amount of money they feel like they earned. All right, the over and above what they would have been willing to settle for. All right, so graphically this involves the supply function in terms of price. Price is what comes out, quantity is what goes in. And so we're still looking in the first quadrant, and so the picture that goes along with this, all right, supply is an increasing function. So again, this would be the quantity would represent my X value, number of items supplied and sold. The y-axis would be my price, usually in dollars per item. We always start at 0. And the producers, the supply function, is always increasing. So it either starts at the origin. A lot of times it'll start at the origin, but not always. So I'm going to draw it above the origin. This would be how many they would, again, be able to give away. We're willing to give away if the price was set at 0. And it's usually an increasing function. So a lot of times ours are parabola, so I'm going to draw it with a slight curve to it. All right, so there's my supply. All right, my supply function. All right, then I'm going to mark off a point. Again, this would be the current price and current quantity. So this would be the market price and quantity. So I'm going to mark off that box again, the revenue generated. So this would be the X value, which would be the current items. This would be the price, right? That would be the dollar amount, the price, the current price. Alright, so the box still represents area, which is still my revenue. So the area that is the box, that dotted line, is still the revenue. Right, it's the amount the company gets based on the sale of their items. So that area, the box area, would be still price times quantity, right? That revenue, this whole thing in my dotted line. So again, if I highlight that, this whole box area, that's my revenue, right? Price times quantity. The one we're looking for is this here. Up here, where I'm kind of drawing over the pink. I might do a different darker color. Alright, so this part here is the producer surplus. Alright, so above the supply curve, but within the revenue, because right, the revenue is what the producers get. Alright, so this area here, it's kind of highlighted above the supply curve, that area is my producer surplus, and that's what we want to find. Alright, so we're looking for the producer surplus. They get all of the revenue, so they get the total revenue, the total box area, but they would have been willing to settle for less than that, alright, which would be the area under the supply curve they would have been willing to settle for, this pink area. Alright, this area below the supply curve is what they would have been willing to settle for. All right, that revenue below there. They got the total area. They would have been willing to settle for the pink area. And so that sort of mix match color up there is the extra that they got. That's the producer surplus. All right. So there's the area we're looking for. So now we're going to set up the equation. All right. So first in words, so the big area is the revenue, right? That's how much the producers get. And so the producers get the revenue, right? So this would be the revenue, which is the current price times the current quantity, and they get that. They would have been willing to settle for less than that. And so the amount less than that is the area, that pink area, right? Area under the supply curve. They didn't have to settle for that. From x equals 0 to x equals the quantity we're currently at, right? They would have been able to settle for that pink area. They didn't have to. They got it all. Oops. All right, and so what's left over when I take the revenue, the box, subtract away the pink area that's below my supply curve, that leftover area is what I'm looking for, the producer surplus. So now in terms of integration, all right? So this is just the current price times the current quantity. That's a number, right? We'd be selling 10 items, but for $50. So it'd be 10 times 50. Minus an integration, right? Area under a curve is an integral. Area under the supply curve from 0 to our current quantity. And this would be the supply function. All right, so we would take the revenue, subtract the area under the supply curve. What's left over, which will be a dollar amount, it's always positive, is the producer's surplus. And so now I'm going to put it all together, which we'll be doing in applications. We'll be determining the producer's surplus, the consumer surplus at a special time. That special time is when our market is at equilibrium, right? When supply equals demand. And so this is putting both our graphs together, specifically looking at what's called the ideal market. The ideal market, and in most competitive markets, they tend to fluctuate pretty close to this ideal equilibrium point. All right, so an ideal market is when we have both consumer surpluses and producer surpluses are equal, right? That price and that quantity are at the level we want for both the supplier's point of view and the consumer's point of view. And we'll graph the picture where I'm going to graph them both. All right, so putting them both together, right, in the same, and this is what our applications are going to do. All right, so this would be our x-axis, which represent our quantity. All right, this would be the number of items, quantity. Then here would be my price, and it's typically in dollars. All right, so the y-axis is the price. We always draw it in the first quadrant. It only makes sense to have positive items, positive price. And typically supply is, again, we start at 0 and moves up. So there's my supply. And then demand starts high and then decreases. So this is where we'll start. You should always mark off your start. Those are your y-intercepts. You always mark those off. And then the demand curve, again, typically is decreasing. So there's my demand. Right. This is where our market is at. This is the equilibrium point. When supply equals demand. All right, and so this is the price at equilibrium. So my little e just means it's at equilibrium. All right, so this is where our current market is at. All right, we're at this quantity at equilibrium. That's the x value we're currently at. And our y value is the price at equilibrium. All right, so that would be our box. All right, our revenue would be that dotted line. All right, and so above that dotted line, draw a little nicer dotted line. All right, above that equilibrium point, but below the demand curve, well, this is the consumer surplus, right? This area here. This is the producer's surplus, this area here. All right, and I'm going to draw two different colors just to have them. All right, so this blue area is the consumer surplus. All right, this area under my demand curve but above my revenue is the consumer surplus. Oops. Pink, so it's fairly obviously that they're two different colors. All right, and so this pink area, and in producers, FYI, producer surplus is typically bigger than consumer surplus, right? And that's just the way, again, markets typically are. All right, and so those are the two areas we're looking for. I want to find the consumer surplus and the producer surplus. All right, and so those are the two different values. And there's, again, you can either remember the equations that we found on that I set up in the previous two examples, or you can kind of just figure it out. It has to do with the revenue and the area under my supply and demand curves. And you just be careful which one you're looking for. Consumers go with the demand, producers go with the supply. And so I'll write down the equations one more time. And so I'm going to start off with and I'll do them in the colors for the area. So consumer surplus, which is the blue area I have drawn there. All right, so the blue area is under the demand curve, right? One of the edges is its demand curve here. The big area would be the area under the demand, right? The big area would be the area under this demand curve from my x equals 0 to my equilibrium x. And so we find the area from 0 to that equilibrium quantity under my demand. All right, but that would be the total area. We don't want the total area. Then we subtract the equilibrium revenue. All right, equilibrium price times equilibrium quantity, right? The rectangular area we subtract. And that would be my consumer surplus, which would come out a dollar amount that should be positive, right? So consumer surplus should be a dollar amount, and it's always positive. If it comes out negative, you've set it up wrong. All right, now the producer, there's my consumer surplus. All right, consumer surplus. All right, so now I'm going to erase it and draw the producer surplus. And then the last set of notes are going to be applications. We're going to apply this. All right, so now the pink area. All right, so now the producer surplus. Oops. There, pink area. All right, so producer surplus. Right, the big area for the producer surplus is, you can notice the big area is the edge of the box. All right, so the big area would be the revenue, so that goes first. So it would be the price at equilibrium times the quantity at equilibrium. Right, that's how much money the producers get. They would have been willing to settle for less. Well, the part I want to get rid of is the area under the supply curve, right? The area under the supply curve from 0 to my x value. And so I want to subtract away this area here. All right, so minus the area under the supply curve, so integrating from 0 to my equilibrium quantity of my supply. All right, and that will give me my producer surplus, which again should come out as a dollar amount that's always positive, and it's usually bigger. It's producer surplus, and if you look at the picture, I've drawn it that way. Producer surplus typically is more than the consumer surplus. It's just the way it works. And so those are the applications that we're going to do in the next video, and then we'll be done. All right.